Hello everybody. In this video we're going to see binary search. Using iterative logic we are going to implement it. Let us see what is binary search and we will implement. What is a binary search? I'll just explain with an example. Say you want to search an element in a list. So for example we are going to have a list of integers. So we have an array which is having integers. There are 9 integers. So the indices are given in the second row. 0 to 8 indices. The elements are 42, 73, 25, 7 and till 82. So there are 9 elements present in an array. So if you want to implement binary search logic to find the element that is present in this array, we need a sorted array. The array should be sorted. So for example, if I sort this array, I will be getting like this: 7, 14, 25 up to 82. So this is sorted array. It's an ascending order, it's sorted array. So we have a 0 to 8 indices. The same array is sorted now. So the first requirement in applying binary search logic to find the element in a list of elements is to have the list in a sorted manner. Why do we have this sorted manner? I will explain to you. Say for example, if I want to search number 8 presents, whether number 8 is present or not, I want to search in this list. So as per the linear list, if we go, linear search will just compare the number 8 with one element one by one. First we'll compare 8 with 42, 73, 25. It goes from first element to last element if you apply linear search. But in case of binary search, we need a sorted array. For example, it is sorted, we got it. And you just have to compare the element to be searched with the middle element in the sorted array. So what is the middle element of the sorted array? 65. So if I compare this 8 with 65, 65 is bigger than 8 and this array is sorted. Okay, so after 65 the elements will be more than 65 because it's a sorted array, that is guaranteed. So the elements coming after 65 will be more than 65. That means the elements coming after this middle element 65 will be more than 65. See for example 72, 73, 75, 82 all are bigger than 65. So the left side of 65 all elements will be less than 65 because it is sorted. So where is the possibility of 8 being present? Is it in the right side of 65 or on the left side of 65? So it can present in the left side. That is possible because middle element is 65. So the possibility of 8 lying is in the left side. But if its array is not sorted, if you compare with the middle element, 8 can be in the left side or on the right side because it can be anywhere. It is not sorted, there is no ordering. So here it is ordered. It's an ordered arrangement. So in this ordered arrangement, increasing order arrangement, if I find 65 in the middle, all the right side will be more than the 65. All the left side will be less than the 65. So 8 will be in the left side. So by doing this one, what I am doing, by comparing with the middle element, we are omitting half of the elements that is present in the list. So for example, in this case, we are omitting all these 4 just by doing one middle element comparison. I am omitting all the elements that is in the right side of 65. There is no need to go and look in here because array is sorted. So 8 cannot present in the right side of 65. It can present only in the left side. So for every middle element comparison, we are reducing the problem size by half. So earlier there are 9 elements. Now I just have to worry about 4 elements only. So I'll compare. After one comparison, the problem size here means what is the array size we are searching. So on which we are searching. So first of all I have array size which is 9. Now I just have to worry about the array size which is having 4 elements. Okay, array size of 4 elements. So the problem size got reduced. So for every middle element comparison, we are reducing the problem size. Okay, so that is the logic of binary search. Now I'll just tell you an example here. So we have array, we sorted the array and we found the middle element. The middle element, so first iteration starts by finding the middle element. So how to find the middle element? This is array given and the indexes goes from 0 to 8. So starting index is 0, ending index is 8. So just we have to sum up 0 plus 8 divided by 2. I'll be getting the middle index. So the middle index is left index plus right index divided by 2. So left index is 0, right index is 8 divided by 2. It gives a quotient. Double slash gives a quotient. Then I'll be getting 4. So we got the fourth index, that is 65. So that's the middle element. So I compare the element to be searched 8 with the middle element. So 65 is more than 8. So where is the possibility of 8 being present? It's in the left side of 65. So now array size is reduced, only 4 elements. So this is a new array. So if the array is there, for example, array size is reduced, array size will go on reducing till the array size becomes 0. We are going to use this logic. Okay, now the array size is 4. So array is still present. That means we are going to iteration 2. So again I will take the middle element. What's the middle element here? 0, 3. 0, 3, 0 plus 3 by 2 is 1. Okay, because double slash will give a quotient. It's actually 1.5. Quotient is 1. Okay, so it'll give. So here if you see this thing, this is the array we got, right? So what is the change? Earlier we have a left index is 0. Here right index is 8. This one, left index 0, right index 8. So 8 plus 0 by 2. Okay, once we found out that the possibility of 8 can be present, maybe present in the left side of the 65. So once we have done that, you see what a change has happened, because the left index is same, only the right index is changed. What is the right index? Earlier it is 8. Okay, now the right index is 3, because the next iteration I am using 0 plus 3. Earlier 0 plus 8, now it is 0 plus 3. So left index is same, because in this left side list of 65, the left index is 0 still. But the right index, I am moving this 8. Earlier it was 8 was right. Now this is a new list. What is the right index value? Middle index minus 1. That's what you have to remember. So middle index minus 1, that is 3. So earlier middle index is 4. Since we found out that the left sub list only we are going to search, so the sub list middle element we have to find out. For finding sub list middle element finding, so you just have to use the 0, which is the earlier previous one's left index, and the right index alone is changing, that is 3. So that is mi, middle index minus 1, 3. So the new index is new middle index is 1. So 0 plus 3 by 2, it is 1.5, 1. So this is the new index. So if now we have to compare 14 with 8, because there is a middle element and the element to be searched is 8. I'm comparing, so middle element is bigger. That means where can 8 be? In the left side of 14. So in the left side of 14 there is a value. So there is a list, there is a sub list. Since the sub list is present, you just have to proceed further. So we are going further. Iteration 3, we have to find the middle element. What's the middle element here? The list is same. So if you go to the left side, only the right index changes. So right index is middle index minus 1. So left index is 0, middle index is 1 earlier. So now new right index is 1 minus 1, that is 0. So in this iteration 3, Li is Ri, both are same. Okay, that is 0. So 0 plus 0 divided by 2, I will be getting 0th index. So this is the middle index. So we are comparing with the middle index. So 7 less than 8. So 7 is middle index value, and 8 is the element we are searching. So 8 is bigger. That means where can 8 be? 8 can be the right side of 7. Is there anything in the right side of 7? Because this itself is a single element list. So there is nothing in the right side of 7. So we are stopping. Okay. One more example, let me see. Say if the same list I want to search 82. So we start with the iteration 1. Middle element is found out. So that is 0 plus 8 by 2. Middle element is found out. Okay, after that 65 is compared with 82. So where is the 82 possibility in the right side? So now I am going to find the middle element for this one. So what is the change? Earlier this is the left index, this is the right index, this is the middle index. So once you are going to the right side, right index will not be changing. Only the left index of the new list will be changing. What is the left index of new sublist? It is middle index plus 1. So it is 5. So 5 plus 8. Okay. So what is 5 plus 8 divided by 2? That will be my middle index present in the new sublist. So this is a new sublist. This is a new sublist. Okay. So this is iteration 2 actually. So this is iteration 2. So iteration 1 middle element finding. In here, from here onwards it is iteration 2. So 5, 8. So 5 plus 8. 5 plus 8 is 13. 13 slash 2. Okay, if you use 13 slash 2 it is 6.5. So if you use double slash it will just give the quotient alone. So 6 is the middle element. So we are comparing 82 with the 73, which is the middle element. So 82 is bigger than 73, that means it's in the right side further. So what is the right side? Element is present or not? Yeah, element is present, 75, 82. That means we are going for iteration 3. So this is iteration 1, this is iteration 2, iteration 3 we are going. So this is the next one. So what is the new list left index? Okay, mi plus 1. Mi plus 1 is 7. Right index is same. So it is 7, 8. So the iteration is here. Iteration 3 is going on. So 7 plus 8, we have to find the middle element for this one. 7 plus 8 is 15. 15 by 2. 15 by 2 is 7. Okay, integers is 7. So this is the middle element. So middle element is compared with the element to be searched is 82. So we are comparing with 82. So 75, 82. 82 is bigger. That means 82 can mean the right side of 7. So right side of 7 means we have to change the left and right indexes. So right index is same. Left index will be mi plus 1. So it is a only one element list. So it is left index equal to 1, right index is equal to, left index equal to 8, right index equal to 8. 8 plus 8 divided by 2, still 8. So this is the middle element. 82 is compared with element to be searched as 82. So if it is both matching, we form the element, right? So it just goes on happening like this. Okay. So when you are having the element which is not present, say for example in this case where this element is not there, say for example what is this li, this is li, left index, right index, both are 0, divided by 2, I will be getting the same middle index equal to 0. Now as per this comparison, what is happening? 7 and 8. 8 is bigger than 7, that means it's in the right side. The right side means we just have to change the left index. So mi plus 1 is equal to new left index. So what is the new left index? 0 plus 1. 0 plus 1 is 1. But what is the right index? 0. So when they crisscross each other, say for example left index can be less than or equal to right index. But if left index becomes more than right index, that means list becomes empty. That is where we have to stop further. So in this case, actually technically how we are stopping, 7 is less than 8. That means if 8 is present, it should be the right side. So we just have to change the left index of the earlier the new sublist left index should be the earlier one's middle index plus 1. So middle index is 0, 0 plus 1 is 1. So left index is 1, but right index is 0. So left index is more than right index. That means they crossed each other. Left index crossed each other. So left and right will go on coming where the element sizes go on getting reduced. When they cross each other, that means now there are no more elements in the list, not even one. That's the meaning that you have to stop processing further. So let us implement this one. Say for example, this is the array I got. The same array we are using here, 42, 73, 25, 7, 75, 72, 82. So the same array I'm taking here, which is present in array A. So first of all, what is the need? It needs to be sorted, right? So a dot sort. We just put it sort. So if you see print A. So now the elements are sorted. Elements are sorted as in here, right? So it is sorted now. So 0 to 8. So what is the first step? Iteration 1 starts. So we will write a simple function to do this searching. Okay. So I will write a function, say for example def binary search using iterative method. So the number to be searched I am passing here, so it is SC, search element. Okay. So here what is happening? What is the left index? Initially left index equal to 0, right index equal to 8. So Li Ri. So Li is 0, Ri is 8 here. This is 8. So that I am putting here as a variable. Okay. So Li is 0, Ri is 8. Initially we put up. And here we are going to find the middle element. So iteration 1, finding the middle element. So middle element finding is Mi is equal to Li plus Ri / 2. So in this case Li and Ri are global variables, so we'll just mention Li Ri here global. So Li means left index, Ri is right index, so it's global variable here. This is present inside the function SC, and Mi is a local here. So Li plus Ri by 2. So when you do /2, we'll be getting the quotient. So I'll be getting Mi equal to 4. So the middle index is arrived at. 4 is the middle index. So now say for example I'm passing here binary search. We are just calling this function from this point, and I am just asking whether 8 is present or not, because we are searching 8, whether 8 is present or not. Okay. So once we found the middle element, what we have to do? We just have to compare, going on comparing. So iteration 1, iteration 2, iteration 3. Likewise, it goes on happening. Iteration 1, 2, 3. Okay. So we are putting it in a loop because there is going to be many iterations. So for each iteration, the loop runs. Okay. So when we are stopping the iteration, when the left index crosses the right index, that means when the left index becomes more than the right index. So what is the condition to perform? Left index should be less than or equal to right index. So it can be possible that Li equal to Ri because it's allowed. That means it's a one element list. But in the case of Li becoming more than Ri, that means 0 elements present in the list. Okay, there are no more elements present. That's what the meaning. So if Li is less than or equal to Ri, then it is valid to go and search. So that is where we are going. So we find the middle element here. So you'll have to find the middle element inside this, because list is valid. Once the list is valid with elements, I'll find the middle element. Once the middle element is found out, we just have to compare. So what we are comparing, if element to be searched. What is the element to be searched? It is present in SC. Okay, so SC is compared with the middle element. So here, if SC is more than our element is in A. Okay, A of Mi. So what is A of Mi? A of Mi is 65. Okay, so A of Mi is 65. So I'll just put this one on the left side as per the same way. So if A of Mi is 65, this is percent. So first we are finding whether it is more than, right? So if A of Mi is more than SC, what we have to do? It is more than SC. So if it is more, if the middle element is bigger than the search element's possibility of presence is in the left side. So when you are going for a left side, you just have to change the right index of the previous list. So what is the right index of the list? It's here. So we don't need to change anything in the left index. So new right index will be Mi minus 1. So in this case, Ri equal to Mi minus 1. Mi minus 1, right? So if it is same, first of all, before doing this one, we'll just find out if it is same. If it is same, what to do? If it is same, that means element is found out. Say for example, if I am searching for 65, imagine instead of 8, if I search for 65, I got the middle element. 65 will be equal to 65. That means we just have to finish it off. It's present, right? So if it is equal, so first if it is present means what we have to just say, we can just pass return true if it is present, right? So if it is not present, then we are going for elif, and then if it is more than, we are changing the right index. Else, what is the category? It will be less, because this condition makes sure that the list has some numbers, at least one element is present. So that means we can directly put else here. So in this case of we are just assuming that all are unique elements, right? So in this case, if this is less than the element to be searched, say for example, the middle element is less than the element to be searched, means the element to be searched in the right side. So in the right side means in this category, say for example 82. So middle element is less than the element to be searched. That means the new thing has, so the element can be present in the right side. The right side means we just have to change the left index. For the new sublist, the left index will be varying, not the right index of the previous. So here li is equal to mi plus 1. Okay. So now we just so here it will return true if it is present. Otherwise, it will run the loop. So return will end the loop if it is present. Okay, it will come to the called place. So otherwise it will go on running this one. So when it will come out of, because of this one, li less than or equal to ri, it will come out. So if it come out of that one, that means I'll just put in that indent of while, I'll just say return false. So in this case, so how this will be hit? Only if the while loop is over. When will the while loop be over? When this is true, when this is false. That means if li cross over ri, that means li more than ri, it will come out of the while loop, it will come here. In that case, we never found the element. That means it returns false. So in this place, we'll just put if. The whole function call can be put upon if. So in the case of true entry, we'll just put print element found. Element not found. So likewise, again, so this is the code for binary search using iterative concept. So if you want to run this and see, so we are passing 8. So let us run this code. Element not found. 8 is not present. Okay. 8 is not present here. So in this case, if I change it to say 62, 62 is found. I'll go for 82. So 82, I'll just change it here. 82 search. We're passing element found. And then if you go for 42, the boundary values, element found. 25, this would be element found. Okay, so it's all present. So in this case, you can return the index also in the present category where it is matching. If you return the index, you can just tell where the element is found out, which index the element is present, you can just say. Okay, so this is the code for binary search. This is the main code. We have just put up in the function. So I hope you might have gained something in this binary search. Thank you for watching the video.